Hello, we're going to look at some more chance work today. We're going to look at problems involving chance, sometimes called written probability. We have already looked at sample space, equally likely outcomes, and probability calculations. If you don't remember them, go back to the previous videos. And we're going to combine them now to solve problems. This is a type of problem you might get. So, a letter is selected randomly from a pile containing, now I like to highlight, express and normal post letters. All are destined for the suburbs of Tin Town and Rockville. We have set up two-way tables before, and we're going to look at the chance or probability of picking a letter, express letter, that goes to Rockville. So we set this up, and these are all the possible outcomes. So the sample space is Tin Town Express, Tin Town Normal, Rockville Express, Rockville Normal. And when we express this probability, remember the shortcut we had, that the probability of the express letter to Rockville, that's straight out of the question, and that goes in the numerator or top, and underneath is all of the different ones that we've got. So of course if we want an express to Rockville, it's 1 in 4, isn't it? So therefore it is 25%. Another sample, the probability of an express letter to Rockville, as we did before, from 200 letters this time, in the pile of 84 of the 120 express letters that are gone to Pinetown. So the express letters, 120 went to Pinetown. We will have to do a subtraction to work out how many letters have gone to Rockville, express letters. The number in the pile, remember, is 200. So let's look at our formula again. Express letters to Rockville, we calculated. The number in the pile is in the question. We worked it out again, and the probability, when you divide 36 by 200, you end up with 18%. Now, it's a written question. It's a sentence, one sentence. You need to write a sentence. So when the number of favourable outcomes are different, the probability will change, and so shall not be calculated using the sample space. So we didn't use that sample space that we had up here, because we had different numbers here. Let's have a look at some questions. You've got a couple of pages of questions, I see. I do believe you may not even have this, so you might need to go back and have another look, or copy particularly this part here. Copy that down so that you can refer back to it. You have a couple of pages, 3 pages of questions, I see. Quite a few questions for you to work your way through, and I believe you have a cheat sheet at the back. Now we've already covered the sample space, equally likely, the language, the formulas, the experimental and the theoretical, and we're looking at the notation. We covered all of those in the previous videos. Okay, back to our questions. Question 1. Now let's have a look. We have one wing of the hospital has nurses, doctors, cleaning staff and administrators working there. 2 of these workers enter one patient's room one at a time. So let's do a sample space first. We need to complete this table. Now it's very easy to complete this table. Remember, we just put in brackets, come down there, NN, and then we come down here like that, and it's DN, and you continue and fill it all in. Check that you filled it in accurately before we continue. We've got all of those inaccurately. They're not accurate, we won't get the right answer. Okay, let's go back now and look at the question. It says the number of doctor and nurse in any order. So we have a doctor and then a nurse, but then we'd also have a nurse and a doctor. So a doctor and a nurse and a doctor. So we would have 2 if they came in any order. What will be our sample space? We have 4, 4, 4, 4. We have 16 in our sample space, don't we? Now we need to calculate our probability. Remember, the probability of a doctor and a nurse is the 2 over the 16. And when you divide 2 by 16 and press the percentage button, you'll get 12.5%. Now let's use some actual numbers. Remember, highlight. There are actually 22 nurses, 16 doctors, 8 cleaners, and 2 administrators working on the wing. Now we need to calculate, it says a percentage of workers that are doctors and nurses to the nearest whole percent. And then we need to explain briefly how this will affect part D. This part here. Will it be 12.5%? If not, why not? Okay, so percentage of doctors and nurses. So the probability now of a doctor and a nurse. So we have 22 nurses and we have 16 doctors. And of all the workers, we have the 22 nurses, the 16 doctors, the 8 cleaners, and the 2 administrators. We need to multiply that by 100 to get the percentage. And add them all up and divide. You will get approximately 79%. Remember, we rounded to a whole percent. If there was a decimal that was 5 or bigger, and it was 78, we need to become 79. Now, this is what you need to think about. This is the sort of question for an A. The result in D is that each outcome was equally likely. Remember the words equally likely. That's what we were looking at in question D. However, we have approximately 79% of our staff are nurses or doctors, not 12.5%. So it's more likely, isn't it, that they are going to enter the room. They're the sorts of words you will need to put into an explanation. And who would be least likely? That, of course, would be the 2 administrators. There's only 2 of them and all 48 workers on the wing. 1 page down, let's keep going. We're on a roll. Now's your turn. Question 2. Work out your Jan's chance of flipping a tail, Lizzie's chance of flipping a tail, and Mark's. Remember, this is experimental, so it's not going to be 50%, is it? They're asking you to calculate decimal, experimental. Same formula, it just won't be 50% very often at all, will it? And then use your calculator. Using your calculations, their combined results. Put it any closer to it being 50%. So you now need to join up Jan, Lizzie and Mark's results and work out their probability and talk about whether or not it's in closer to the 50% than each individually. Have a go. How did you go? Jan was quite good at flipping tails. Lizzie's good at flipping tails too. Mark wasn't so much. But when you put them all together, you have the 3 scores of flipping a tail and the 3, so it's out of 150 this time, simplified, and then you divide it. So it's now much closer to the 0.5, so it's 0.49 recurring. None of these were close to the 0.5. Combined, they're very close. It is much closer than the 0.5 that you would be expecting. Good. Now question 3. Digital photo frame. Selecting random pictures that you've stored. Okay, 100 photos, so highlight. Here's all the numbers you need. We're going to be displaying 300. So frequency of each word, 150 of Fiji, 66 of birthday and 84. We now need to work out the theoretical and the experimental, that they should match. So experimental, you end up with 150 out of 300, 50%. You started with the theory of half of them. That was correct. However, with the birthday photos, you will find that they were quite different, and the zoo ones were as well. Have a look at those answers. They do not match. Then the digital photo frame is not working properly. It said it would do it a certain percentage, and it hasn't, has it? It said they would do that percentage. That one they did right, this one it hasn't. So something is wrong with our digital photo frame. And your last page. Remember to highlight. So spinners spin a blue counter wheel and a red counter wheel. Blue and red. The blue value minus the red value is how much they move. This means you must move backwards if you're on a negative answer. So the first player to land on across the finishing line wins the game. So you've got to sit here now and work out all of these. So remember, it is blue minus red. So 1 minus 1, 2 minus 1, 3 minus 1. I think you can find the pattern there and fill them out. Here we've got 1 minus 2. It's a negative number. 2 minus 2, 3 minus 2. I think you're starting to have a pattern. Fill that out. Do you have the correct answers? You must have the correct answers to move on. So check everyone has been done correctly, and then we can move on. One player is 5 spaces away from the finish line. Write down all the different coloured number combinations that will give the player a result of +5 or more. So you need to go back. You need to find all the +5s or more. And you need to write them down. So here is all your combinations that you're going to have to write down. +5 or more. Okay. 2, 4, 6, 2, 4, 6. We've got them all. There are only 6 that could be there. So, what resulted in a win? We just said there were 6, didn't we? Different spin combinations, if we count them all up here, how many have we got? 8 by 8. 8 eighths are 64. So, as a percentage to 1 decimal place. Very simple. We're going to have the number we want, which we worked out to be 6, divided by 64, the total sample space. And then we're going to put that in a calculator, times 100. And to 1 decimal place is 9.4%. So at 9.4%, go back to that table here. 9.4%. So it's very, very unlikely, almost impossible, isn't it, for somebody to win. So you would need to say it is highly unlikely that a player will win. The last one is you have to now comment on the major flaw in the way this game allows players to move compared to the number of possible forward and backward movements. You have to think very carefully about that, using the information you have already. Yes, so have you said there is an equal number forward and backwards? This means you will never finish. You're never going to finish. Well done, guys. Remember, keep this cheat sheet, refer to it often, and good luck.